This is Differential Equations, and we're in section 4-2, and it's called the Method of Elimination. And it's not really that. What it really is the same thing you did ever since 9th grade algebra. Except this time we're doing it, when you solved 2 equation 2 unknowns in 9th grade algebra, you didn't have any derivatives involved. But this time, we're going to have derivatives involved. So we'll start with problem number 2. And we have x prime is equal to x minus y prime. No, minus 2y. And y prime is equal to 2x minus 3y. Okay. And we find that if I would to move this over a little bit so that I have more room, I will do that. All right, so if we look at this guy, we find that 2y is equal to minus x prime plus x. And so y is going to equal to minus x prime over 2 plus x prime over 2, plus x over 2. And then we look at y prime. We're going to take that guy and take its derivative, and we say that's minus x double prime over 2 plus x prime over 2. Okay, and we say, well, that's the same y as that y. So we could write that 3x minus 3 times y, which is that guy there, minus x prime over 2 plus x prime over 2, actually just x over 2, is equal to minus x double prime over 2 plus x prime over 2. Okay, so everything seems to be all right to that point, I would hope. And now we can just combine like terms and multiply by 2, because we have a half everywhere. So we're going to combine like terms, multiply by 2, and we're going to have that minus x double prime plus x prime is equal to 4x plus 3x prime minus 3x. And we can regain those guys, manipulate around a little bit. X minus x double prime minus 2x prime minus 1 is equal to 0, and we can get rid of all the negative signs. X double prime plus 2x prime plus 1 is equal to 0. And we find we have a characteristic equation of m squared plus 2m plus 1. And we find that that's m plus 1, the quantity squared, and is equal to 0, and that implies that m is going to be plus or minus 1. No, just plus 1, minus 1, minus 1. Minus 1, minus 1. So that being the case, x of t is going to end up being c1 e to the minus t e to the minus t plus 2c2t e to the minus t. Okay, well, if that's the case, then x prime, and that'll be a final answer for x of t, and x prime is going to be minus c1 e to the minus t plus c2 e to the minus t minus c2t e to the minus t. Okay, and seeing that y has to be minus x prime over 2 plus x over 2, from up above, we find that we're going to have minus c1 e to the minus t plus c2 e to the minus t minus c2t e to the minus t, everything divided by 2, plus c1 e to the minus t plus c2t e to the minus t divided by 2, and we combine those terms together and find that y sub t is going to be c1 e to the minus t minus c2 e to the minus t over 2 plus c2t e to the minus t. And that would be the final answer for there. Now, we're going to look in the back of the book and we're going to see that that's correct. Okay, now we're going to look at problem number 6. And I've got x prime is equal to x plus 9y. And y prime is equal to minus 2x minus 5y. And I have initial conditions. X at 0 is 3, y at 0 is 2. And if I wasn't in this chapter, I would use Laplace Transforms. But I am in this chapter, so I'm not going to do that. I'm going to go and say that, I'll rearrange him and say y is equal to x prime over 9 minus x over 9. I'm going to say that y prime is x double prime over 9 minus x prime over 9 and I'm going to see that that's equal to minus 2x minus 5 times y, which is x prime over 9 minus x over 9. Okay, and I'm going to look that over a little bit, and I'm going to say, well, that's going to boil down to x double prime plus 4x prime plus 13 x is equal to 0. So I'm going to multiply everything by 9, so I've got a minus 19x. And then that's going to come over to the other side of the equation. And then here I'm going to have a plus 5x. That's going to come to the other side of the equation and give me the 13x. And I think you can see where the other guys are coming from. Okay, well, I have a characteristic equation m squared plus 4m plus 13. I can complete the square and say that that's m plus 2, the quantity squared, plus 9 is equal to 0. So I'm going to come up with my m's are going to be minus 2 plus or minus 3i. So x of t from the characteristic equation is going to be e to the minus 2t quantity c1 cosine 3t plus c2 sine 3t. And we can't count that as our final answer because we have initial conditions. Okay, so I've got that. And I have an initial condition that says x at 0 is going to be 3, which implies that c1 has to be 3. Okay, now, so I'm going to, for the rest of the problem, we'll work with x of t is equal to e to the minus 2t 3 cosine 3t plus c2 sine 3t. And we said that y was equal to x prime over 9 minus x over 9. Did we not? Yes, right there. Okay, I'm going to do that again. I don't know that you can see my marker moving around, but it was up there. Okay, so y is equal to 1 over 9 quantity. The derivative of the x guy minus 2 e to the minus 2t 3 cosine 3t plus c2 sine 3t plus plus 3 e to the minus 2t 3 sine 3t, that's a minus 3 sine 3t, plus 3, the 3 already came out, so I don't need that 3. That 3 is already on the outside. Plus c2 cosine 3t plus actually it's minus. See that minus sign? So we'll get rid of this plus sign. Minus e to the minus 2t c1 cosine 3t, and that c1 is really a 3, so we'll put a 3 there, plus c2 sine 3t. Close parentheses again, because everything is divided by 9. Okay, so I combine things together and I get y is equal to okay, so I've got a 3 here, I've got a minus 2 there. Okay, so I'm going to have 1/3 e to the minus 2t minus 3 plus c2 cosine 3t plus minus c1 minus 3, that's a minus 3, minus 3 minus c2 sine 3t. Okay, I'm going to apply an initial condition. Y at 0 is 2. So if y at 0 is 2, then y is equal to 2, which is equal to 1/3 times the quantity minus 3 plus c2. Okay, so this is going to be a 1. Goes on the other side, it's a 3. It's going to be a 1/3 times, turn it over, 3 times 3 is 9. So that implies that C2 is equal to 9. So, final answers. X of t is e to the minus 2t, 3 cosine 3t plus 9 sine 3t and y of t is equal to e to the minus 2t 2 cosine 3t minus 4 sine 3t. Okay, and I think those are probably right. So we'll move on to number 6. Number 10. I just did number 6. Number 10. X prime plus 2y prime is equal to, well, 4x plus 5y. And 2x prime minus y prime is equal to 3x. And I have initial conditions x at 0 are 1, x at y at 0 minus 1. Okay, so first thing we're going to do is try to get these in the same form that we had the first two problems were in. So we'd like to have them in the form x prime is equal to something in x and y, and y prime is equal to something in x and y. So that's what we're going to do. And we're going to say, we're going to, first thing we're going to try to do is get to a normal form. Okay, so that's what we're going to try to do. So, so if I multiply the bottom guy by 2 and add it to the top guy, I'm going to have 3x prime is equal to something, right? I'm going to multiply it by 2. So I'm going to have 5x prime is equal to something. Okay, so that's what I'm going to do. I'm going to multiply the second guy by 2, and I'm going to add it to the top guy. And I'm going to get 5x prime is equal to 6, that makes it 10, 10x plus 5y. So I'm gonna have an x prime is equal to 2x plus y. And then I'm going to want to get to a y by itself, y prime by itself. So if I multiply the top guy how am I going to get to the y guy by himself? Oh, well, I can get the y guy by himself. So I have 2x prime that's 2 times this guy. So that's going to be minus 2 times 2x plus y. Okay, so I'm putting that guy in there, then bringing this guy over there, minus 3x. So I end up with y prime is equal to x plus 2y. Now, let's see, what did I do wrong? Oh, right, minus that is minus 2 times this. And when I do that, I end up with I don't know what I end up with. Okay, well, let's see. This is a minus. That's going to be 2x prime, which is going to be minus that. This is going to be plus that. Okay, now I'm good. I have minus x minus 2y with a minus sign there. I get rid of all the minuses and I'm there. Okay, so now I've got two equations in a form that I can handle it. And I'm going to say that y prime, y double prime, is equal to x prime plus 2y prime. And that's going to equal x plus 2 times minus 2x plus x prime. And I'm going to end up with x double prime what am I doing wrong? Okay. Let's move back a little bit. Okay, so that's going to give me y prime is equal to x plus 2y. Okay. And from up above, what do we have? We have y up above we have y is equal to minus 2x plus x prime. And so y prime is going to be minus 2x plus x prime, double prime, x prime, too many primes. Okay, so y is equal to that, y prime is equal to this, but y prime is also this guy, which is x plus 2 times y, which is minus 2x plus x prime. Okay, combining everything together, we have that x double prime minus 4x prime plus 3x is equal to 0. We have a characteristic equation. M squared minus 4m plus 3 equals 0. We can factor that m minus 3, m minus 1. And we have m is going to be 1 and 3. So x of t is going to be c1 e to the t plus c2 e to the 3t. Okay, now from up above we have that y is equal to x prime minus 2x. Y is equal to minus 2x plus x prime. Okay, so that's what we're going to use, that guy right there. Okay, so y is equal to x prime minus 2x. And we're going to have c1 e to the t plus 3c2 e to the 3t minus 2 times c1 e to the t plus c2 e to the 3t. And we're going to get that y of t is equal to minus c1 e to the t plus c2 e to the 3t. And now it's time to apply the initial conditions. So x at 0 is supposed to be 1, which is going to be c1 plus c2. And that guy right there. And y at 0 is supposed to be minus 1, which is going to be minus 1 minus c1 plus c2. Okay, well, if c1 plus c2, if I add these guys together, I get 0, I get c2, which implies that c2 has to be 0. And if c2 has to be 0, then c1 had better be 1. Okay, so for my final answer, I get x of t is equal to e to the t, and y of t is equal to minus e to the t. Okay, good enough. Okay, moving on, and that checks with backup book. Moving on to number 14. Okay, number 14. And I have x double prime equals minus 4x plus sine t. And I have y double prime is equal to 4x minus 8y. And I don't have any initial conditions, so I don't have to worry about them. Don't know if that's good or bad. Okay, so if I look at the first equation, I have that x double prime plus 4x is equal to sine t, and I have a characteristic equation of the homogeneous solution that says m squared plus 4 is 0, which implies that m is going to be plus or minus 2i. So x of t, the complementary solution, homogeneous solution of t, is going to be c1 cosine 2t plus c2 sine 2t. And I've got a particular solution. And x of p is going to equal a sine t plus b cosine t. Oh well, can't have any signs if I can't even spell sine. So I'm going to have to find a particular solution. X prime at p, x double prime p minus a cosine minus a sine plus, that isn't right. That's better. Minus a minus b sine minus b cosine. And I want one of those guys And I want 4 of these guys. And when I get done, I want to have sine. Okay, so 4 minus 1 is 3. 3a sine. 4 minus 1 is 3. 3b cosine. So b has to be 0 because there is no cosine over there. And a had better be 1/3. So I've got an answer for x of t. Final answer x of t. That doesn't mean I'm done. That just means I have a final answer for x of t. Final answer x of t equals C1 cosine 2t plus C2 sine 2t plus 1/3 sine t. Now, isn't that lovely? So now we'll ask ourselves, do we need a new piece of paper? Yeah, we probably do. Okay, so we'll get a new piece of paper and say, well, from the second equation up above on the first piece of paper, we had y double prime plus 8y is equal to 4x. That's what we had. So y double prime plus 8y is equal to 4 C1 cosine 2t plus C2 sine 2t plus 1/3 sine t. Okay, well, that looks reasonably okay. All right, I have a characteristic equation, and that's m squared plus 8 is 0, implying that m is going to be plus or minus 2 the square root of 2. So y sub c of t is going to be we'll go with C3. C3 cosine 2 the square root of 2t plus C4 sine 2 the square root of 2t. And okay, that's good. And guess what? We have a particular solution. Y sub p is equal to a cosine 2t plus b sine 2t plus c sine t plus d cosine t. Isn't that lovely? And y prime sub p minus 2a cosine long 2a sine plus 2b cosine plus c cosine minus d sine. And y double prime of p minus 4a cosine minus 4b sine minus c sine minus d cosine. And I want one of them, 8 of those guys, none of the guy in the middle. And when I get done, I'm going to want something. And I'm not going to have much room to get it either. Okay, so I'm going to want 4c1 cosine 2t plus 4c2 sine 2t plus, I'm going to want 4 over 3 4 over 3 sine t. So that's what I'm looking for when I get done. Okay, so I've got 8a minus 4a is 4a, and cosine 2t. I got 8 minus 4 plus 4b cosine 2t. I got 8 minus 1, 7 sine, 7c, sine t, plus 7d cosine t. Okay, that looks good. Alright, so my d has to be 0. My A has to be C1. My B has to be C2. And my C has to be 4 over 21. Okay, so final answer. Y of t is equal to, make sure I have enough room to write it all, C3 cosine 2, the square root of 2t, plus C2, C4 sine 2, the square root of 2t, plus C1 cosine 2t, plus C2 sine 2t, plus 4 over 21 sine 2t. We'll clean that up a little bit, and this will end the first part of 4-2. We still have a second part to do. There's still 1, 2, 3, 4 more problems to do, which we'll do in the second part.